If two resistors with resistance R1 and R2 are connected in parallel, as shown in the figure, then the total resistance R measured in ohms is given by 1 over R equals 1 over R1 plus 1 over R2. And if R1 and R2 are increasing at rates of 0.3 ohms per second and 0.2 ohms per second respectively, how fast is R changing when R1 equals 80 ohms and R2 equals 100 ohms? Okay, so for this problem, we're going to need to differentiate this equation, but first we need to solve for R since we're given R1 and R2, so I'll go ahead and start off by doing that. So I'm just going to go ahead and plug in my numbers. R1 is given to be 80 ohms, and R2 is given to be 100 ohms. So from here, what I'm going to do is I'm going to use my calculator. 1 divided by 80 gives me 0.0125 plus 0.01, which gives me 0.0225. And in order to solve for R, you need to flip the reciprocal. And what that means is that you're going to get 1 over 0.0225, which gives you 44.4 repeating ohms. There you go. So this is our value for R, and it's asking for us to find how fast is R changing how fast is R changing. So that's going to be dr over dt, and that's when we're going to need to differentiate this formula. So I'll go ahead and rewrite it. And I want to first show an example of what the derivative of 1 over x is going to be. So if you don't know your rules, I'll just tell you this is going to be negative 1 over x squared. The reason being is that 1 over x is equivalent to 1 over the power of negative 1. And when you're finding the derivative, what you want to do is that you bring this number down, negative 1, and then you subtract 1 from the exponent. So I will give you negative 2. And this is equivalent to negative 1 over x squared. See, and that's how. So yeah, just want to clear that up because we're going to we're going to have to use this in order to differentiate this formula. So let's see, negative 1 over r squared plus dr dt, I'm sorry, times, and then negative 1 over r subscript 1 squared times dr subscript 1 dt. I'm going to have to erase this. Plus, actually it's minus 1 over r squared subscript 2 times dr subscript 2 dt. All right, so from here, I'm going to go ahead and isolate dr dt, and I'm going to do that by multiplying both sides by negative r squared. So giving me, since there's already a negative in both terms, you can go ahead and multiply, or rather, well, the negatives, they're going to get rid of each other since there's negatives on both sides. That's what I'm trying to say. So I went ahead and multiplied both sides by r squared, and I'm just going to rewrite it. All right, so then from here, I'm going to go ahead and plug my numbers in. So R, we found it to be 44.4 ohms. So that's going to be 44.4 squared. And R1, it's given to be 80 squared times d r1 over dt, which it gives us to be 0.3. I'm just going to go ahead and write 3/10 so it's clear. R2, they tell us it's 100, so 1 over 100 squared times 0.2, so it's 2 over 10. And you put brackets. Yep. All right, let's continue. So 44.4 squared is 1,975.3. And once you plug this into your calculator, 80 squared you're going to get 4.69 times 10 to the negative fifth plus 2 times 10 to the negative 5. And from here, let's just go ahead and add these two numbers up. Giving us 6.6875 times 10 to the negative fifth. Then you multiply that with 1,975.3, and we get that dr dt is equal to 0.132 ohms per second. So that right there is our answer. All right. Thank you for watching.